Hello, so we need to be able to transform graphs, and here we're going to look at translating graphs. The philosophy with any transformation is what we firstly do inside function f of x, we do the opposite, which affects x. And then what we do outside the function, we do what we expect, which affects the y values. Okay, so what does that mean then? So in this example, we need to sketch firstly y is x squared, so that's the standard x squared graph, right? It looks a bit like this, right? Y is x squared. Then part B, we need to sketch y is x minus 2 squared. Well, if we say that f of x is x squared, then x minus 2 all squared is the same as f of x minus 2, right? And so then what we do inside the function, we do the opposite. So what this would mean is we subtract 2 to x, which would move it 2 to the left, but actually do the opposite and add 2 to x. So all the x's increase by 2 and we shift to the right. So the x squared graph, we shift to the right by 2. So it would look something like that, and then it'd be at 2. And then the y-intercept then, well, if the y-intercept then, well, when we set x to 0, then y is going to be minus 2 squared, which is 4. So it'd be 4 there. Okay, and then part C, we need to sketch y is x squared plus 2. So then if f of x is x squared, this is f of x plus 2. And so that's outside the function, so it does what we expect, and it affects y, okay, the y values. And so what we expect, we add 2 to y, which means all the y values increase by 2, meaning the whole graph goes up by 2. And that's what happens, right? And so the x squared graph shifts up by 2, and so it will look like this. And so the y, then it will pass through the y-axis at 2. Okay. In this question, we're told that the point R of 6 minus 4 lies on the curve y is f of x. We need to state the coordinates when it's transformed to now y is f of x plus c minus d. So where does the coordinate transform to under this new function here? Well, again, with my philosophy, 6 minus 4, if I transform it, well, firstly, f of x plus c. So this plus c is inside the function, we do the opposite. So so the opposite of plus c is minus c. So we're going to subtract the x by c, so it's going to be 6 take away c. Then the minus d is outside the function, so we do what we expect. So we subtract d to y. So the y value of minus 4, subtract d. And that's my coordinate. Okay, so we've got this question here. So I'll add my roots on. So I've got this function of the curve here. And I need to first state how many roots the equation 2x cubed minus 13x squared at 8x plus 46 equal to 0 has. How many real roots? Well, actually, notice it's pretty damn similar to the function of the curve, but instead of 48, I got 46. So what I can do instead is split this up to 48 take away 2 equals 0, because then that goes to 46. I've not changed anything. So then I can say that equals 2. So solving that equation is corresponding to setting the curve equal to 2. So if I draw a line y is equal to 2, right, then we can spot that actually there are going to be 1, 2, 3 intersections. So therefore 3 roots. So therefore say that 3 intersections with the curve y is f of x and y is equal to 2. Therefore 3 real roots to the equation, right? And then for part B, we're told that k is a constant, and that the function is modified to y is now f of x plus k, and the curve passes through the origin, right? The curve passes through the origin there. And so the two possible values of k, what this is saying then, again, the plus k is inside the function. So what we expect is add k, but we're going to do the opposite and subtract k. So we're going to shift by k. Okay, so we're going to add or take away k to x, so it's going to shift it left or right. Now the curve can only shift left or right, move left or right by k units. So if we want if we want to shift the curve to make it pass through the origin, it would either look like this, right? Well, minus 1.5 would then map to 0. So if we want to firstly map 1.5 to 0, so minus 1.5, 0, that coordinate, right, the root. If we want to map that to 0, 0, the origin, well, we need to add 1.5, right? So that means our function has to be f of x take away 1.5. Okay, because we do the opposite. If we want to add 1.5 to x, we need to subtract 1.5 in the function to do the opposite. Okay, and then the other possible shifting, we could also move the point 4 to 0, right, the origin. If we do that, the curve will look something a bit like this. Something like that, if we shift it 4 to the left. And so that coordinate for 0, that root for 0, if we want to send that to 0, 0, the origin, then we need to subtract 4, right? From 4 to 0, subtract 4. So the function to enable this is x plus 4, if we do the opposite of minus 4. And so therefore, my two possible values are k is minus 1.5 and k is plus 4. And those are my two solutions for k.